All right, folks. Good morning, good afternoon, good evening, wherever you guys are. Thank you for this edition of Kubevela Community Call. And yeah, we'll start with some housekeeping first, and then we have some guests over here who've been using Kubevela for some time. We'll go to them after. First step, we've released a new version of Kubevela. Brian, do you want to give a little update of what it includes?
Yeah, it's just some minor bug fixes. So some ergos were blocked by validation logic. So if you had a trait included on a component that had data passed to it through a workflow, validation would fail. So it was a bit of an obscure bug. So that's now fixed. Our structured logging that we added recently was missing the component type, which made it kind of difficult to monitor some stuff. So we added a fix for that. And there was a third fix, which is escaping me, but I'll just quickly look it up. Um, oh yeah, so if you deleted a component from an application and then the new revision went out, the status fields would still be left, so it would still be health checking the old components and it would kind of leave them orphaned. So it now correctly removes all the status fields on deletion of a component.
Perfect. Thank you, Brian. And a little update on the dev kit implementation. I think we are progressing well. We have about 80% done and tested. And Ayush here, if you could give a little bit of update on where we are with our implementation of dev kit. And for those who don't know about DevKit, it is a Go CLI based translator from Go definitions using Fluent APIs into Q. There is a KEP that's been there and merged for that. And please take a look. And if you have any comments and anything else, we can definitely include those as well. Um, Ayush, do you want to give a quick update?
Yeah, sure. So in DevKit, most of the definitions which is built in, supported in Kubevela is translated and is present and working. So some of them have some bugs around the translation, which we are continuously fixing in a loop and extending the Fluent API support for it. So I think in a couple of weeks we should have all the definitions up and working.
Awesome. So our hope is to get that released sometime in the March timeframe, and we'll go from there. And along with that, we have our friends from Comcast who are here, and they have been using Kubevela for quite some time and quite extensively. And we'd love to hear from them on how they're using. And after that, we can have any open questions anybody in the community has. Over to you,
Okay.
Sergey.
Uh-huh. I'll start. How much time do we have?
We usually have about till an hour from 8, but usually we don't go that far. So if you want to split the presentation into two parts, like cluster
Mhm.
management and app management, we can start with the apps because that's
Okay.
what Kubevela does right now, and we can do the cluster management part in the next.
Mhm.
Yeah. Anup, we
Um,
also had another item in the agenda, but if you don't get time today, then we can push it to the next edition by
mhm.
Chaitanya.
Sure.
Yeah, so sounds good because we can spend any time to get to details, but really I want just to introduce us and just understand what kind of interest is there, and then we can go with other next sessions if needed to dig deeper. So my name is Sergey. I am engineer in Comcast and going to pair here with Parani, who is also engineer um, in the team. But we also have I saw quite a few other people from Comcast joined. So we have a pretty solid team at this point. Um, just we started with the platforms long time ago. We were early adopters of Cloud Foundry and still have hundreds of thousands of workloads running on Cloud Foundry. And our developers love it because of easy to use, opinionated. Here's my code, host it for me. I don't care how. So you probably all know this Cloud Foundry or Heroku things, and we are really using it at huge scale. But same time, not all the workload fits in Cloud Foundry. So when Kubernetes came up in existence, then we started to use it to also leverage to extend type of workload that can run on our platform. So our platforms are opinionated platforms built both with Cloud Foundry and Kubernetes. And while doing this, we are taking very careful approach in what we are bringing in our environment, in our platform, how we build them, and we call it intentional architecture, so also quite common term. And trying to pick up very carefully different components and make everything composable so we can evolve the platforms over years. And at some point, we did introduce Kubevela to our architecture and retired, some other components that we were using before. So you see, it's a constantly evolving life cycle of managing high-level opinionated, highly skilled platform. So here's definitely not trying to talk and explain everything about the platform, but specifically around Kubevela, where it fits. So we have a opinionated UX, we call it Bossa Nova, on a top, and I'll dig a little bit deeper there. Then we have a Kubevela as an absolutely great way to have a real composable, reusable components that can be used to create different kind of solutions with the same sort of reusable architecture. Obviously, we have a whole fleet of specialized controllers, and you know many of them very well. And also recently we introduced Sveltas as an add-on management for our clusters. So also important part of this architecture is not just have a declarative way for developers to define something, but also to get the feedback. So how status is filled. So I'm pushing my application. I want to know, are we there yet? Is it ready? Is it all running? So that is also some complexity. The last slide I want to show before a short break and see feedback from you guys is the use cases that we are covering with the same kind of architecture is pretty wide. So we have like a cluster as a service, cluster as a code. So we can deploy Kubernetes clusters, or not the platform engineering team, but our developers, our users can self-service dedicated Kubernetes cluster for them on a different infrastructure. We can manage applications, web services, AI, job running and stuff like this. So there are different kind of applications we can cover. And also we manage databases, distributed, local, all kind of data solutions, not just databases, but messaging and so on. So all orchestrated with the same kind of backend. Now I'm going to pause. Are there any questions, specific areas you guys want to focus on?
This is great, Sergi. I think it's quite a lot and something I think we should cover. But I'm just wondering if we need to split this across two sessions.
We
Um,
can. We should.
that way we can keep everything and a little tidbit of for others to join in on how good this is. Um, can we go to the applications because that's probably where we
Okay.
use Kubevela most, and then we can go to the other two aspects after. But if I may, and if it's okay for you to share, um, how many clusters are you running and how many workloads are you running on with Kubevela?
So the number of clusters is measured in hundreds. I frankly I don't know exactly, and I don't want to care much.
I think
Bef-
that's an amazing way to think. I don't care how many classes I have because they just work.
yeah, because our point is to engineer the solution for a self-service and not necessarily, manage them individually. Yeah, cattle, not pets. But it is in hundreds, definitely more than 300, but I don't know the exact number. And in terms of the workload, so this web service and Piranha has more information, but we have hundreds of thousands of workloads across Kubernetes platforms and Cloud Foundry. And I think at some point we passed, so we had more on Cloud Foundry because it was before Kubernetes, right? But at this point, we have more on Kubernetes than on Cloud Foundry.
And they are all running as Kubevela applications?
No, no. So again, we are evolving,
Okay.
and so Kubevela was introduced at some point. We used other technology before. So through Kubevela, I it's way less. So it's definitely less than 100,000, but my guess is on in tens. But I'm trying to do engineering, not operations.
No, fine. But I just want to make sure the users get a scale of how much it has helped.
Yeah, and also I don't know how much I should talk about this as well.
And that's totally fine. I think that's all I had. I'll let you run into your
Yeah.
presentation.
Okay, so I'll let Parani talk about the web service, but here's a very high-level diagram. And most of the things probably very familiar to you, other than Bossa Nova, which is our UX level. So it is essentially, you can think, so now there is a CRO, right? So Kubernetes Resource Operator. So you can think as this layer that allow to create a custom resource definition that people will use. That CRD will enforce schema, do validation, and also very simple to use. And then it translates to much more complicated Kubevela application definition. I can actually give you an example. So that's Parani just created 10 minutes before this call. So this is how web service looks like. You see a very, very short definition, but the actual, it rolls into very, very long and complicated OAM. I'm going to stop talking and better give time to Parani. He knows better. Parani, do you want to share your screen or go through mine?
Maybe can you help me to get into the architecture diagram, Sergey?
Okay.
Yeah, it is there in your repo. Yeah, cool. Hey, hi everyone, this is Parni here. I just wanted to cover that how Kubevela was awesome to give a better developer experience, right? I want to talk about the piece. So we are part of developer experience team. We love Kubevela and we know the value of it, but we wanted to take this into the developer, not directly, right? So since we are a platform team, our developers doesn't know, no need to know about anything, right? All they need is have an application. I want to ship it. So you guys do whatever, right? I just have this few information. Just take this information and give me my app URL. So we wanted to create this experience for our internal developers in our company. So that's the outcome of this whole architecture, right? I'll talk with one use case. Let's say I built an application, I have done code, and I make code is my repo, my GitHub code here. And yes, that's it, right? If any information like environment variable, I need to pass it here, or at a very basic level, customer can fill these details, create this simple manifest, and they can just do kubectl apply to our platform, right? What we are doing, as Sergey mentioned, we have the blueprints, and we do have convert this simple abstraction to an kubel application, right? Kubel application object with policies and workflow and component traits. So we do have a lot of opinions, right? This platform is default, like auto scaling is by default, right? We do put that minimum instance and maximum count of that application instance, and by default application will be distributed into different regions, right? Even we will give them the flexibility to they can choose the region, but still by default we distribute it into multiple regions so that application is a default redundancy, it can gain the default redundancy, all those things. So how we achieve it, we abstract everything and give the simple layer to the customer. But under the hood, Kubevela does the complete orchestration. We have a high level component called, you guys know it, right? The web service component. We just modified a little bit around that, and we have the necessary traits in place, HPA, props, all these things. And we are leveraging policies at the high level. And by have all these combination, we are able to, deploy all these things in few minutes or a few seconds, I would say it. I would say, right? So this is the whole experience. I will just wanted to pass it here, and I have the live demo. If want, I can. If you have a time, I can show the live demo, the application experience, right? The deployment experience. You could see it here. But before that, I just wanted to stop it. And any questions?
Yeah, guys, please drive this because we can talk for hours and hours. Just we want to focus what is important for you.
I think this is great, Bernie. I think you should continue. I'm forming a lot of questions. I'm sure others in the call are also. And if you start with the questions, you may not finish the presentation.
Awesome. Cool.
But this is
Uh,
great.
cool. Okay. Before getting into the demo, few lines. Right. Kubevela help us to talk to the vault, right? So we use Kubevela for leveraging a lot of toolings, right? Like, yes, we are using ESO for vault integration. So customer can simply, right? Hey, this is my vault path, right? Please get my secret and, put into the application. So these are all awesome features. We are able to enable it through this Kubevela orchestration. Fine. Okay. So again, I wanted to share my screen and yeah.
Yeah.
Okay. Okay. Sorry. Okay. Yes, we have that simple application, and okay, I'm just going to watch this and I'm just going to deploy this application. Boom. So you could look at here, deployment is initializing and it's in progress in a few seconds. It's a very simple, lightweight API, I would say, right? That's it. With few seconds, you can, oh my God. Where is my, okay, I'm just going to hit it. This is a completely secured SSL URL. That's the demo.
It happens. Maybe it's not up yet.
It's up. Yes, that's
Oh,
what. Because we haven't checked that status, right? During the deployment itself, we kind of tried it. And that's it, right? Like you hit it, you see different, IPs. So under the code, we distributed into different region. Yeah, that's an experience, right? Like our developer is getting. Yeah, it's very quick because it's very lightweight. And to be honest, if it is Java, I mean, based on that, the startup time or whatever, right? The time will take different. But the experience is something similar. You come and create few lines of manifest, and you get an application deployed and with completely secured and company, alliance and complaints, right? So all these things.
Yeah, just to emphasize that when this is happening, it's not just one single cluster. It deploys actual workload, like deployments on multiple regions on multiple clusters. It configures auto scaling, probes, and everything. It configures our global ingress. So global ingress is a concept that we have to do distribution to have a very resilient infrastructure for distributing applications across multiple data centers, not just distributing, but the ingress layer. So there is a build service that compiles, build from code to the image. So again, we can bypass it by providing an image, but most developers want to, here's my code, close it for me.
Yeah, that was a haiku for Cloud Foundry. Here's
That's
my
right.
code.
Right.
Fantastic. Yes, it's good that people remember that. We're just creating a similar experience, and again, the goal is still the same as Cloud Foundry, right? Here's my app, run it for me. I don't have to build the infrastructure. I don't have to maintain it. It, you can make it compliant to your company's security compliance. Very little things you have to do from an infrastructure standpoint, right? And also by default, not only is it secure by default, it is fully distributed, right? Across different regions and wired all together. So when you have an idea, you want to go from idea to production in a matter of minutes.
Did we leave now?
Yep.
It's
Yes.
Cool. Yeah, thank you. That's exactly what we want with Kubevela as well, is to abstract to a level where it actually makes sense that the developers, as platform engineers, you can provide that abstraction, which developers can then use with minimal knowledge of what happens behind the scenes. So it aligns well with what CloudFoundry used to do. Barney, if you have any more to show, or if not, we can go into questions. I have a few that's running in my head already.
Yeah, we can go with the questions. More than showing everything. Like to hear the thoughts and discussion around that.
Cool. This is
Yeah.
great. It's good to see that you build the abstraction on top of it based on your company's requirements for the policies, etc. And I think, Sergey, you mentioned about blueprints, and I think your Bernie mentioned about blueprints. So do you have different types of blueprints, or is it just one blueprint for all apps?
Mm-hmm. We have a different type of blueprints for different use cases, right? So for example, we have a web application. That's one use case. It has one blueprint. We have, jobs, right? So it's another blueprint. We have clusters, another blueprint. Actually, for clusters, we separate by infrastructure. So like AWS cluster is one blueprint, OpenStack cluster is another, and so on. And databases, right? So we also do databases as a service the same way. So we have a whole bunch of different database technologies, and we have blueprints for each. So it's essentially like CRD to blueprint, one-to-one mapping.
And in the example that you showed, Parni, I didn't see a reference to a blueprint. So is that within the GitHub repo?
It is internal, so blueprints are hidden here, so it is internal thing. So blueprints is what used by Bossa Nova controller.
Okay.
So blueprint is what platform engineering is developing.
Fair. Okay.
The user are using the blueprint through this web service in this case, right? So when they're saying web service, that's what developer is saying.
Okay.
Now, platform engineering has a blueprint for a web service.
I see.
Blueprint translates essentially the custom resource to in this case, OEM application. It is actually does not always have to be OAM, doesn't have to be Kubevela application. So Blueprint translates that layer to that abstraction to anything what is in Blueprint. But we are very heavily using Kubevela for this. So again, you can think about it as a for example, cross-plane XRD, right, where you can define different resources and how to create from XRD, from CRD, from CR, the actual a bunch of resources. So in this case, the blueprints is that translation layer.
Okay, good. So I have a good, thank you. This is Jerome here. I have a question. So like cross planes, are you enabling composition of blueprint? You were mentioning web service type of blueprint on database, and this is very common that usually developer want runtime as a web services on multiple data store or storage. So how do you express that?
Sorry, can you repeat? I missed the storage part.
Yeah, what I was saying is usually a developer, when they define an application, they have a runtime component, so more web services.
Yes.
And often they need a data store with it, a database, an S3. And so I'm wondering how they are expressing that.
Parani, do you have a handy example of this?
Yeah, I do. Okay, let me take it and share my screen again.
Yeah, while Parani bringing it up, so we were using the same concept that we learned from Cloud Foundry, and again, that concept our developers are using. The concept is managed services that are bound to applications. So a developer can create a database service, a backend service, like I don't know, Postgres database or RabbitMQ or something like that, and bind it to an application. And the process of binding is essentially create secrets and inject that secrets to the application. So this way we have full self-service. Developers can create backend services as well as persistent backend services as well as applications and connect them together without touching secrets, without copying secrets to their laptops or environment variables or anywhere.
It's cool. I have I'm going to hold my mouth for some time. Anybody else have any questions from the community that you guys are thinking about?
Yes, so that's on the screen is an example of a service claim, right? So the database is a MongoDB kind, right? So again, it's created separately, so there is a separate definition for MongoDB. So same way as defining applications, people can define a Mongo database, and then this way you can connect that Mongo database to an application. And there are different methods of connection we provide. Like one is environment variables, is service binding, and so on.
Okay, thank you.
Sergey, you mentioned that web service is a blueprint, right? That which you have in the backend, which the application developers use. Do you have like similar blueprints for configuring DB resources or cloud resources as well? Like what Jerome was mentioning, or
Yes.
you just directly pass it as a parameter here?
No, so that MongoDB is implemented exactly the same way.
Okay, it's a blueprint again. Okay.
The use cases, so the same way we implement not just web services, but we implement durable jobs or databases, different database technologies, messaging, and so on, as well as cluster deployments. So if somebody just need a dedicated cluster for whatever reason, if they have something unique that cannot be fit in opinionated basket, then the same way people can create a new Kubernetes cluster just for them. Or for some testing, they can use it for 20 minutes and delete. It's full self-service. And again, it is going through the same flow custom resource definition on the top for, in this case, cluster. When they apply, we have the bossa nova gets a blueprint for cluster definition and translate it to Kubevela object, and then that Kubevela object orchestrate deploying of everything else. So, like in case of cluster, we are using cluster API and things like that. So that is the same flow across.
And for these blueprints, do you have like a central consolidation place where you maintain all these blueprints and the versions of it and so on?
Yes, so we maintain it in a GitHub repository, and it's just literally a directory structure, a repository with a directory structure, where we have a different blueprints. Like in this case, web service is literally the name of the kind, and it is the name of the blueprint as well.
Okay.
And by the way, so we are using for blueprints, we are using Q language as well. So that plays very well with Kubevela.
Yeah.
Perhaps you love Q. I think it's because we used to use all kind of things like YTT and such. But since Q was discovered, that's our go-to.
And what about your deployment strategy? So you have like a central consolidation place, like a repository, and then how do you manage the deployment to prod and so on? Do you have like a versioning mechanism?
Yeah, so it is actually the same for blueprints as well as for Kubevela definitions, right? Because in this case we create tons of Kubevela definitions, our own traits and components and everything. And so we have a library of those definitions. So they're separate from blueprints. So it's complicated, but we have a library of Kubevela definitions, and we have a library of blueprints, and then we have a CD flow whenever things are changed in a main branch, it gets pushed to control plane nodes, servers, clusters, right? Because they don't need to be on the workload clusters; they all in a control plane.
Okay. One last question. Sorry. So is it that every single change that you do, Sergey, gets pushed directly into this, or do I have an option as an application developer saying that, okay, for MongoDB, I want to use a specific version in my application, not the one which is now available in the central repo?
Very good question. The answer is no, developers do not have this choice.
Okay.
And actually, one of the hardest thing in all this is lifecycle management with versioning. I can very quickly. Oh, Parani, can you show an example of a cluster definition?
Yeah.
So in a nutshell, you decide this is the version of MongoDB which gets deployed by the application developers, and they don't get a choice out of it, right?
Yes, they don't have a choice at this point, and we want to have an opinionated way to upgrade, right? Because when we push a new version, we don't want just automatically upgrade everybody, because there is a risk for that. So yeah, show my cluster. So you see line 5 is a version of that cluster. So and it's not like we're universally applying this technique. So we're trying to find the right way. But the idea here is that if a definition has a version, then it will pick up a blueprint of a specific version. So this way we can control how customers upgrade, in this case, the clusters, but it can be applied for databases and other workload as well. So the point here is like every every few months we roll out a new high-level release, right? And that release can contain tons of small things. It's configuration changes as well as, for example, new version of CNI or something like this. So we bundle it in this kind of releases versions, and what we want to do is to provide users ability to upgrade on their schedule. So instead of us like on Monday pushing a new blueprint and it automatically upgrade all customers' clusters and create all kind of issues. We don't want that, right? So we want users to be ability to say, hey, I just want to bump this version to whatever is new, and it will upgrade my cluster on my time, and I will verify it. So overall lifecycle management is different, and also we don't want people to hang too long with old versions, right? So we can say that if it's not upgraded over 3 months, we are going to upgrade it for you.
Got it. Yeah. Thank you.
Good.
But
So
that's literally the overall release management, lifecycle management, and versioning is the hardest part, including in Kubevela. So there is some room we might want to focus and improve in Kubevela as well.
And
yeah, that's
sorry, go ahead, Jim.
good. Yeah, no, just to continue on what you were saying. So you were covering some actions, some day to action, typically the upgrade. So some are disruptive, requiring downtime, and some are not disruptive. So how do you manage the disruptive one so that does the user decide when it is done? On production, do you have some specific maintenance window?
So there are both, right? So one is on infrastructure layer. So for example, that as you saw in the diagram there, web service infrastructure contains 8 clusters, right? So control plane cluster, 3 workload clusters, 3 index clusters, and the build cluster. So we can put any cluster, any region offline, do maintenance, and then bring it back. So we are trying to do non-disruptive upgrades, but sometimes, and control plane is a single cluster, and build service cluster is also a single cluster, but if something is happening and those clusters are not available for half an hour, that is not a huge deal because all the production applications continue to work, right? So it's literally orchestration of changes. So that's why we have an extra redundancy in a actual lines. So, but we do have a very strict policies in Comcast for change management. So if there is something that is disruptive, we notify users, we schedule it, we do it in a safe way. But also we are trying to minimize and make life cycle as less disruptive as possible. So this is on infrastructure on a platform side. On a customer side, for example, they want to upgrade a Postgres database from a previous version to a new version. That probably can be disruptive, right? So that's where we want to give them self-service ability so they can do it on their own schedule. So it's not something like we are doing. It's here's the mechanism for you to self-service changes. Do it as you wish, right? And they apply, their own policies in terms of maintenance windows and so on.
Okay, that's great. That's great. So your customer, are they all internal Comcast, or do you have external customer, people outside Comcast using the infrastructure?
Well, Comcast is a large organization, and it contains of multiple companies. So yes, it is like in Europe. It's Sky is a Comcast company, right? So we also rolling this out currently to them, so they don't use it yet, but it's on the way. NBCU and so on. So yeah, it is Comcast family. let's put it
Okay, I see.
Yeah.
Okay, good. Thank you.
So in this diagram, actually, the multi-cluster setup, are you using Kubevela multi-cluster with topology groups to achieve this, or is there a separate multi-cluster kind of setup here?
I have this.
Parag,
Yeah, you can continue. Like, I have the same question as well.
Yeah. So we are using the policies, right? The topology, as you said. In that policies, we said that, what are my workload cluster, right? So deployment, certain resources are goes to that, but certain, we can tie that policies to particular workflow step, right? So that's how we apply that certain topology for those particular objects. Example, for deployment objects, alone goes to particular cluster through that policies combination.
Yeah, and what is important here are health validation and health checks, so we can do safe rollout and stop rollout if there are any problems.
Yeah, one of the thing was we were looking for it, right? Like while deploying, health check will fine, but after we deployed it and something goes wrong, Kubela was not able to reconcile, right? We had kind of that problem, but looks like the latest revision we fixed it actually. So while testing out with the latest release of Kubela, we addressed that health check issue. So
Yeah, it should
that,
constantly reconcile. And just on the multi-cluster, so one of the concerns we have is the hub cluster needs a high amount of permissions into the spoke clusters with
Mhm.
static credentials, and we're a bit, we have concerns about like.
Okay. So for our architecture, right, we are not allowing anyone to any of this workload cluster or any of these things, right? So customer will have access to the particular namespace with the complete RBAC. So yes, we have a system namespace in our platform, especially in this control plane cluster with tight security policies on top of nobody can read any secret, even us, right? So yes, Kubela have maintaining all the kube config and everything to whatever the cluster it is connected to. It is still using the RBAC to connecting to those workload cluster with kube config and stuff, like the way how it works. But in terms of securing things, we don't allow any tenant to any other namespace, and there is a tight RBAC has been set it up. Even our own team, platform team, can't read any secrets, especially around the cluster in the system namespace as well. So this is how we are managing.
Yeah, and that is another and one of the primary reasons for having that bossa nova layer on top of application object, right? Because we want to use Kubernetes native RBAC and very strictly control what people can do. So the developers really communicate with the control plane cluster, and they can't start any random deployment there or pod there. So they can only provision like databases and web services and connect them and manage their own secrets, stuff like this.
Got it. Okay. And then, I mean, it sounds like in your use case, platform engineers are building the abstractions in Kubevela, like your Q definitions, but the audience is other platform engineers who then kind of compile them into workable blueprints to distribute to developers. Is that?
Yeah, so it's all part of a platform engineering job to create blueprints as well as to maintain this environment. We would love to sort of inner source that, but we are not doing it at this point. We just talk to our our developers, our customers in this case, and get their feedback and incorporate in the blueprint. So it's all managed by us, and everything is exposed to developers through custom resources that they can manage themselves. So
Cool.
they don't have ability to bring their own blueprint, because that would really create a security concern, as blueprint can contain anything. So we are
Perfect.
using native Kubernetes custom resource as a the interface, as a UX, and through it we manage security and versioning and everything.
Is the blueprint a one-to-one with underlying resource? If I understood well, you had the web service and the database. Are they two separate things that the users have to create separately? And then the ordering of those things, how is that managed?
Yes, so in this example, right, so in this example, there are two, Brian, if you put on line 14, we'll put 3 dashes. That will help.
Okay, I'll cover this part, right? Okay,
So,
basically, yeah.
go ahead.
This is the manifest for example, a database, right? So if any developer need a database, they will just create this manifest, this custom resource. They will get on a DB, and then they can come and they can bind it here, right? Like this, with their application, they can simply bind that DB like this in their spec, like any other field. So they can simply bind the DB which has been deployed already. So we will do the wiring, everything.
So if they want to deploy a database, they need to do that first and then
Yes.
wait for that to be created and then put it into the web service as a binding. You kind of lose the beauty with Kubevela, where you can combine certain blueprints as you go as a user. You're not concerned about that, I guess.
Yeah.
Just comment on this. So it's not need to wait. It's not the order. So the order is not important, and the reconciliation happened as in a normal. Users declare, and even the order of declaration is wrong, then it will just the application object will wait. Web service will wait until a database is ready, and then we'll create this binding. But you're absolutely right that these are two different blueprints. And in this case, the MongoDB is fully autonomous blueprint. It creates a database. But the application web service blueprint has a special portion that is saying, I know about MongoDB, and I know how to connect MongoDB to a database. So every time when we roll out a new database, we need to modify also web service object to introduce how that specific database needs to be connected to an application. But from a lifecycle management, it is there sort of separate, and a developer can completely delete an application and later create a new one binding to the same database, so the data will be safe.
Understood. Yeah, we have a similar setup with the contract between components. We just combine them in one application and let the users choose what they use. But the contract in between the definitions, the Kubevela definitions, it's always a thing we need to maintain and worry about. It's like, how is the application gonna interact with the database? How is the accessing of a secret done? Thank you.
Also, it's one thing we thought of is like it's complete different life cycle, right? TB has its own life cycle. App have its own life cycle, right? For example, TB maintenance, upgrade, or whatever, right? So that's where like we thought of separating out things. Even we can do single manifest, we can combine both, but we kind of purposefully split and maintain the life cycle of DB and app separately.
And if I were to ask another question around the database, do you have migrations that run? Where do they run in this kind of instance? Because you might have a migration, we have a database that needs to be created, then a migration, and then the web service.
So for a database, we have completely outside of this scope. We have ways to migrate databases from different technologies, and we have the whole product called Database Migrator that facilitates these things. In this scope, what can be done? You can create Like if you have a MongoDB, so let's say if you have a MySQL and you want to move to Postgres, so you can keep your MySQL, you can create your Postgres database, you can migrate the data one way or another, right? So some external database migrator or just doing, some other ways, and then you can repoint your application to a new database. So that's one way, right? And so this way you can fully test before switch over. But in terms of life cycle for like existing database, so the user should be able to upgrade just a version with keeping the same data, and that essentially has no effect on the application, other than your application can lose connection for some short period of time and will restart or reconnect or something. Right, because the credentials will remain. Credentials are created and exchanged during this binding phase. Right, so we have creation of a database, creation of application, and binding between them. So binding is essentially creates a set of credentials and connect them together. And this is a concept that we picked up from Cloud Foundry. And
The service broker.
We just carried it over.
Yeah, so I think that the Cloud Foundry has a service broker concept, which sort of like creates a lifecycle outside, and then you can bind it. But like Oana said, Kubevela has a different concept. You could apply the same if you want to Cloud Foundry, and because Kubevela is lower down and allows you to build your own platform on top of it, you can choose whichever. One way is that if you can, the advantage of having everything in one application is then the entire BOM of the application is present in one place, and you know exactly what is it's all there. But as it does require managing those resources perhaps outside, like upgrades, migration, etc., or through a separate set of traits that you can create for those components, like for database migration from version X to Y, and you want some patching that needs to happen that probably runs a job or something else. So there's a lot of things in here. I know we're coming up on time. I just want to make sure that everybody in the community has gotten a chance to ask a question. This has been amazing. It's great. But I also have maybe a controversial question, even though we are part of the maintenance of Kubevela. What hasn't been working for you with Kubevela? Is there things that you think we could improve on, and as a community, bring it all together, make it better together?
I don't know how you want me to start. Is it alphabetically or in a category order? Yes, obviously. I mean, there is no perfect product that rules them all, right? So there are strong things and there are rules for improvement. So we definitely can talk about some specific things, but what we really love is composable nature. So that from the get-go built in a way so it can be very composable and accountable. And I think this is the biggest strong point for us. And being able to maintain our library of components and traits and combine them together to different shapes is a huge value. Now when we moved from our previous architecture, one thing that we wanted to use from Kubevela is workflows. And we very actively start to use workflows. It's because we had a whole bunch of custom controllers that we had to make to manage workflows. And we were trying to evaluate different kind of like a Argo workflow. So yeah, Argo events, Argo workflow for that, but nothing fits really well. And initially we thought that Kubevela would be the one for this, and we start to work with workflows. However, we run into quite a few limitations and challenges. So we are trying to balance how much we are using workflows and where they're going. So probably I think there are potential improvements there. Another thing is what Parani is mentioning is a feedback, right? So when something is changed and change is propagated, So how we can message the events back. So again, like the health check that Kubevela provides is a great, but unfortunately, it's not like a continuous health check. So how that feedback is created. So I would say these are top two on my mind. I don't know if anybody else, Parani, or anybody else from Comcast can expand.
I think you covered pretty much, Sergey. The main concern, like status is the topmost. Since as a platform team, right? So we wanted to communicate back to our customer, okay, what is failed, right? We all see that, deployment is successful, all good. Okay, something goes wrong. We have a 7, 8 cluster. Which
Right.
cluster, which is goes wrong? They will ask, why do I mind? Something is failed. The developer looks like, whether it is working or not, right? So that's kind of improving the status is kind of crucial.
Yeah, that's a big one for us as well. Even though we are maintainers, we also have a company behind that we use this for. So that's a big one. I know my team is also concerned and working on that. But that'd be great. I mean, these are. I mean, if you only mention if you can pick two, I think the platform or Kubevela has done great in a way. So
I will note, as of 110.4 or 5, I can't remember which, it does continuously recheck the status. So that feature is there.
Yes.
And there's also features in there that let you pull out like additional information and return that back to the hub. And there's also some structured logging improvements that let you kind of like capture the events as they're happening, and then it's a better you're better able to monitor them. So those features are all there. So try them out. Let us know.
yeah, I
Yeah,
think
in 1.10.6, isn't it?
But
I think it
Yeah,
was
it was.
10.6
no,
to 10.5. I think it was before 10.6.
I'm pretty sure
Oh,
5 and 6 have been both fixed releases, so I'm pretty sure it went in 110.4.
Yeah. Yeah,
so
5 was a no op release or something like that. So, but anyway, I think if you guys could try those things out and give active feedback, and we'd love taking code and PRs as well. That'd be great. And we'll see next in our next session and listen to what you guys have done around cluster management and etc. using Kubevela. Um, but I want to take this and shout out to the Comcast team, all of them, all of you guys for coming on board, giving us this information. And I'm sure the community appreciates it. We're looking for more engagements with multiple other companies. Anybody else who wants to present how they've done things and how others could, make use of your patterns. Please do come forward and let us know. Um, and thank you. I know we're at the top of the hour. Thank you very much, and we'll see you guys in the next session.
Thank you for having us, and we really looking forward to be a more active part of the community, not just consume the product under closed doors.
That's music to any maintainer's ears.
We'll,
Thank
co-
you.
we'll cover the cluster part in the next iteration, right?
Yes, yes.
Yeah.
Uh,
Perfect.
how Comcast is using it. And
Yeah.
yeah, this recording will be posted on YouTube in a few days. So we'll see you. Thank you, guys.
Thank you, Sergey.
You.
Thank you, Parani.
thank you.
Thank you, everyone.